Hello, algebra students. Mr. Lawrence here, and we're going to solve some more quadratic equations by factoring. Hopefully you're starting to recognize when to use what type of factoring. Remember, we're looking at a test next week, probably Tuesday or Wednesday next week, no later than Wednesday, no earlier than Tuesday. But let's get right down to this. Okay, we have this x squared minus 121. Hopefully you're recognizing that x squared is a perfect square. I'm going to take the square root of it. Oops, I'm not in draw mode. Hold on one second. Take the square root of x squared. And then the square root of 121 is 11, and there is subtraction. So this does fit the difference of perfect squares method, right? All right, well, I'm going to set up my two quantities. And since it's a difference of perfect squares, I'm going to get an x plus 11 and an x minus 11. If I wasn't sure if I did that right, I could FOIL, and then that would show me my solution, or get me back to the original problem, that is. So now that I've done that, I can take each part, each factor, x plus 11 equals 0, solve for x and get x equals 11, excuse me, negative 11. And then, of course, I can do with the other quantity, x minus 11 equals 0, solve for x and get x equals positive 11. So x equals plus or minus 11 is the solution. Okay, if I put 11 in for x, square it, subtract 121, I get 0. If I put negative 11 in for x, I square it, subtract 121, I get 0. Well, let's see number 2 here. Well, 49x squared, I could multiply 49 by 64, but I'm noticing that this is a perfect square, 7x. And I notice that 64 is a perfect square, 8 is the square root. And if I multiply those two together, I get 56x. And if I double 56x, I get 112x, don't I? And look at that, it matches perfectly. So here's how I do that. 7x minus 8, and another quantity of 7x minus 8. And most kids think the difference of perfect squares method is easier, but actually this one is one less step because both signs end up being the same. So now I take 7x minus 8 equal to 0. I solve for x, and I get x equals 8/7. And that's my only solution. I could do it again for this quantity, but I'm going to get the same exact solution, right? Okay, so remember that for the perfect square trinomial, if the first term is a perfect square, the last term is a perfect square. If I take their square roots, namely the 7x and the 8, multiply them, and double it, if I get the middle term, it's a perfect square trinomial. Now, because the 64 is positive, I use the Wendy's double stack. I use that sign twice. Okay. All right, coming down here. Now, one thing I don't think I've stressed enough to you is always do the GCF first. Did you hear that? I said always do the GCF first. Always factor out the GCF first. It doesn't mean there will be a GCF on every single problem, but if there is, factor it out first. And I look here and I see a GCF. You see it? I think I'm going to factor out a 2x. And when I do that, I'll be left with 6x squared plus 21x plus 20. And that'll equal 0. Oh, now let's see here. It's a trinomial. It looks like, well, it's not going to factor super pretty. So I'm going to pretend like the problem, I'm just going to worry about the problem inside the quantity, okay? And I'm going to come down here and I'll multiply 6 times 20, which is 120. And I need two factors of 120 that will add to get 21. And so that would be what, 2 and 60, 3 and 40, 4 and 30, 5 and, oh, I've got a mental blank, 24? Yeah, 24, good. That's not going to work. 6 and 20, that's not going to work. I don't think 7's going in. 8 should go in. If I cut this in half, I get 60. Cut it in half again, I get 30. And cut it in half again, I get 15, right? 8 and 15 should work. Okay, 9 isn't going to go in. 10 is. 10 and 12, right? Okay. And 11's not going to go into 120 evenly. All right, now none of those will sum to 21. So this part in here is prime, but this isn't. So I'm going to take the 2x equal to 0 and solve for x. So the only solution for this right now is x equals 0. Now when we learn the quadratic formula in chapter 10, Miss Eubank will be teaching you guys, we'll learn how to solve something like that. But right now for factoring purposes, we look for the GCF and we factor completely. Okay, we're going to do one more example, two more examples actually, so just hold on a second. I'm going to come back to number 4 in a minute because I hadn't intended for that one to not factor all the way through. Mistake on my part. It's okay that it happened, but let's see one that would have a GCF and then factor further. Okay, let's take a look at this problem number 5 here. And remember, there's a GCF hiding in here. And I think it's actually going to be 4x as my GCF. That'll leave me with a 9x squared minus a 30x plus a 25. Okay, now that 4x is going to stay out front, but this part in here is going to factor further. This is a perfect square trinomial. 3x, and this is 5. If I multiply 3x and 5, I get 15, and if I double it, I get 30x. So this fits the PST form. So I've got a plus in the back, minus in the front, plus in the back, a Wendy's double stack. 3x minus 5, and then a 3x minus 5. Oops, I lost my x out here on the 4, didn't I? Equals 0. Now I have to consider all three quantities. Quantity 1, quantity 2, and quantity 3. So I'll do 4x equal to 0, x will equal 0. That's one possible solution. Then I do 3x minus 5 equals 0. And 3x is going to equal 5. So x is going to equal 5/3. Now I don't need to do quantity 3. I need to look at it, but I realize it's the same exact thing as quantity 2. So my solution here is x equals 0 or 5/3. And there you go. All right, now we're going to come up to problem number 4 here. And some of you are going to get this wrong because you're going to go, hey, x squared is a perfect square. And then 25 is a perfect square. And you go, I know it's x plus 5 times x plus 5. And then you're going to say, oh, x equals -5. But do me a favor. Please FOIL this. Please FOIL x plus 5, quantity of x plus 5 times quantity of x plus 5. Hey, wait a minute. That doesn't match. Oh, I know. I must have factored wrong. It must factor like this. Maybe it's x minus 5 times x minus 5. Okay, well, I ask you to FOIL it. Okay, x squared minus 10x plus 25. Well, that doesn't match either, does it? Okay, so that's not right. Oh, it must be one of each. Silly me. So let's do x plus 5 and x minus 5. And then I'm going to ask you to FOIL it. X squared minus 25. The problem is it doesn't match. It's x squared plus 25. See, you're trying to use the difference of perfect squares. So you're trying to use the difference of perfect squares. The problem is this is a perfect square, this is a perfect square, but there's no subtraction. Difference means subtract. And so you see this one, you can't factor it. You could say this is prime, but since we're solving for x, you'd actually say that this problem has no solution. All right, there you go. That's your video for today. Mr. Lawrence signing off. Have a good night, everybody.